So when you're multiplying scientific notation numbers, one thing we can keep in mind is that if you're multiplying everything, you can rearrange the order of multiplication. Like 1 times 2 times 3, that's the same thing as 2 times 1 times 3, right? You can reorder it, you're still going to get 6. So same thing up here. What you can do in your head is you can multiply 2.8, well, maybe this is a part where we need a calculator, but in your head you can at least rearrange and think about the numbers that have a common base, the 10, being multiplied next to each other. And I changed from a times symbol like that to this times symbol here. But the reason I rewrote it like that is because if numbers have the same base, then their powers just add. So 10 to the negative 6 times 10 to the 5th, that's 10 to the negative 1st. Okay, and then we got 2.8 times 3.9. Oops. It gives us 10.92. And now this is a number that's not technically in scientific notation. 10.92 is not scientific notation because there's only supposed to be one number and then the decimal. One digit, then a decimal. There's 2 digits in a decimal. So we can fix that by just moving the decimal. But think about which way you moved it, right? 10.92, I moved the decimal 1 place to the left. So I shrunk this number. I shrunk it from 10 to 1 point something. So that means I need to balance it by making this number get bigger. I'm going to multiply this by 10 to the 0. Okay? 10 to the 0, and that's actually just 1. So this is the scientific notation for our answer, but 10 to the 0 is 1, so another way of thinking of it is 1.092. I'm not sure which one my math lab is going to like. I don't know how often this will come up or it'll be 0. Like here's another example of multiplication. 3.2 times 10 to the 4th times 4.8 times 10 to the 5th. So I'm going to multiply the plain old numbers. The 3.2 times 4.8, it's 15.36. And then when we multiply 10 to the 4th times 10 to the 5th, that makes 10 to the 9th. But it's not scientific notation. I got to move this decimal 1 place to the left. So I shrunk this number. I've got to balance that by increasing this number from 9 to 10. Okay, so that's what we were doing in that last step. And then same thing when you divide. 7.8 divided by 3.9 gives us 2. And then 10 to the 5th divided by 10 to the negative 7th. When you divide things, like here, actually let's go back. When we multiplied things with common bases, we added their powers. So if you divide things with common bases, you would subtract their powers. So this is 5 subtracted by a negative 7. So that's like 5 plus 7. That makes 12 here. And that's our answer for this one. 7.8 divided by 3.9 is 2. And then 10 to the 5th divided by 10 to the negative 7th makes 12 power, because when you divide, the powers subtract. And we subtracted a negative 7.